Well, welcome everyone. Thanks for coming here to TCMedia for this Intro to Audio workshop. My name is Rocco Strain, and I'm an audio engineer and music fanatic, and I'm really excited to share with you about audio technology today. I use he and they pronouns, and I would love to get introduced to you all. This is a pretty interactive workshop. We'll be doing some microphone testing, talking about equipment, lots of questions, whatnot. So I'd love to get introduced to you. So maybe we can start with you, Tyrone. And
I'm Tyrone Bradley.
And if you can use the mic whenever you're asking a question or responding, that would be awesome.
I'm Tyrone Bradley. I'm a producer, engineer, and a record label owner. Okay.
Hi, I'm Paul Vega, and I play around with GarageBand and iMovie.
One, two, hood. My name is Scotty Sounds. I'm a musician, been a drummer for a long time, but working on my own material with a singer-songwriter.
My name is Lene Reed. I'm a multimedia artist, author, musician, and all-around witch.
I'm Ben. I'm a composer, a pianist, and I'm just starting to make my way into the production world of music. So glad to be here, happy to be here.
You hear me okay?
Yeah.
I'm Reggie Garrett, songwriter and a performer. I've put out about 6 CDs over the years, and I'm here always to learn a little bit more.
Awesome. Cool. So we've got a variety of folks here with different backgrounds, and I'm going to try and cover from the beginning of sound and audio technology, and we can get more advanced, and it's kind of going to be dependent on what you're eager to learn, because there's so much that we can get into. The first thing I want to talk about is like what is sound, and because that's the thing we're trying to work with and capture, represent. So to me, sound is frequency, is impulses of vibration that occur from the vocal cords, from guitars, from space explosions, like things that are creating energy and moving through time and space. And so there's amplitude and there's frequency, meaning like amplitude is how loud or intense a sound is, and frequency is how many cycles per second, how often, or like how fast a sound is moving essentially. And so when we talk about low frequencies like a bass guitar or the growl of a bear, those are very slow moving waveforms, and they can pass through walls, or they're less directional. And high frequencies, like a baby crying, you can hear that from maybe a mile away. It pierces through because those sound waves travel faster, and they have the ability to, we respond to them differently in our ears. And so a big piece of audio engineering is looking at the difference between what's happening, like literally with measurement devices, with microphones, and what's happening with our ears. And so much of making music and recording music and documenting sound is really about what we hear and trying to represent that to the world. And so from an artist perspective, these are all just tools. We've got microphones and mixers and the technology, and learning how to use them enables you to take a concept or vision that's in your head and actualize it. And sometimes it works, sometimes you come out with a different result. And so for me, like audio engineering is observing what happens when you put a microphone, this way instead of this way on an instrument, and being able to be like, okay, like I like the way this sounds, or this brings out warmth and these tones, and then being able to recreate that when you're working with that same instrument, and your intention is to reproduce that energetic reproduction, essentially. So I guess does anyone have any questions on that before I move on? Okay, cool. So let's get into the basic tools of audio engineering. And we're gonna start analog, and so that means just electrical impulses moving through all this equipment, and it just gets transformed from one place to another. And so the first thing we'll use is this dynamic microphone. I don't know, where's the best place to point it? That looks pretty good. Okay, so a dynamic microphone uses something called a moving coil. And inside of here, there is a little like wound up coil that moves in response to air pressure. And that's the same way our ears work, is that there's sound moves through the air, and our cochlea responds moving back and forth to that pressure change, and generates a signal that we process as sound. And so this is very similar in that way. And it's also similar to the way that speakers work. So if you think about like a speaker driver or like a woofer that moves back and forth, this is doing the same thing, but it's actually like the opposite. So this takes it in, and then it converts it to sound with an electromagnet in here. We're not going to get into that in this moment, but it gets converted to sound, and then it gets sent out. Well, I'll show you all. So through the back of this microphone, and I'll pass around this microphone, and you can look at it. So yeah, just take a look at the structure of this thing. And I'll kind of keep demoing as well. So I'm taking off the grill right now, and this is, it's got a little bit of foam on the inside, which is meant to filter out wind noise or pops. And it's got you can't really see it, but there's the moving coil inside of there. There's a magnet inside of here. And then there's these 3 pins on the back side. And there's a hot pin, a neutral, and a ground. And this we connect to an XLR cable, which I believe stands for external line return, though there's a couple differing opinions online. But basically, it's this kind of cable that maybe you've seen before. I'll pass this around as well. And this is a pretty common audio cable. Used to connect microphones, used to connect mixers, and it is a balanced cable, meaning that it has, well, one, you can send a stereo signal over it, left and right, and it has wiring that enables it to be phase compliant, if you will. So actually, I'll get into that in a minute when I talk about the difference between cables. But this is your basic cable for a microphone. You look at your pins, you plug it in. That's just a pro tip. You know, when you're trying to plug a microphone, look at it, see where it is. Saves you time. You'll connect it, and then this runs into something. And so that could be all sorts of things. In this case, we're going to run into a mixing board. And a mixing board is just a place where you have a bunch of inputs and they run through different channels. So this input goes to this channel, they're all identical. And they have certain features on them like EQ, equalization, gain, and your level. And this all gets summed, just like in addition. You know, you take your 2 plus 2, it ends up as 4. In this case, you could take your, actually this has 8 inputs, and they get summed down to 2 channels, which comes out as a stereo left-right, and that's called our master mix. And so you know, you might find yourself in a situation where you're using a mixing board. So let's talk about the options. So basically, your signal comes in, and if anyone wants to see this better, please you come up here, or we'll have a point where you can come and look and kind of make this all make sense. So the signal comes in, and it goes through the gain stage. And gain is your electricity. It's how much power you're sending through the preamp for the mic signal to get amplified. And that's a very sensitive and creative knob. So basically, you want to be able to hear what's happening foremost. So I'm talking through this first channel, and right now you can't hear anything coming through because the gain is all the way down. There's no electricity going through. If I turn it up, it starts to get louder and louder. And if I go all the way, it starts to sound different. And if I crank it a bunch, it can actually distort, which I'm not going to yell into it right now, but I mean, you've probably heard, you know, distortion sounds. And that happens when you overgain your microphone, and it overloads the circuit, basically. And so your goal is to set your gain level to where it's healthy, and it provides enough dynamic range for what you're trying to capture. Meaning, if you have gentle moments, if you're playing a song or if you're talking, and then you're planning to get really loud, you don't want your gain to clip or distort when you get really loud. So you have to figure out where that threshold is so that you can work within it. And so there's also a volume knob, and that is after it goes through the gain stage, this is how much of that signal you're sending through your mix. And so ideally, you've got a nice clean gain signal that's set, and you don't use that as your volume knob. If you need more volume in your overall mix, you just turn up the volume knob. And if you feel like that's cranked all the way, then we might have to come back and look at the signal chain. Like maybe your master fader is too low, and so if all of your inputs are cranked, all the way, and you're still not getting the level of volume that you want coming out, you have to look at each step and see, okay, well, where are the levels? And this is just the first stage of audio, because then it gets sent to an amplifier. And so in this case, this is the speaker. It has a built-in amplifier that powers it, and that's where it provides the bulk of the volume. So if that is distorting, maybe that's too loud. So there's all these different areas that you have to address, essentially. If something's going wrong, or if you want something to change, you basically got to know what each thing does. Okay, so we're going to come back to the next items on our channel strip here. We have a low frequency, a mid frequency, and a high frequency adjustment. And frequency, we can think about on a spectrum. And so basically, if you think about this as the low end of frequencies, which is represented in hertz, cycles per second, the human ear can only hear, down to about 20 hertz up to maybe between 10 to 20,000 hertz. So it's a really wide range, and pretty much all sounds that we're going to be working with happen within that frequency range. And within that frequency range, there's also this axis of amplitude of how loud a sound is occurring. And there's the baseline, which is kind of just like your normalized, when a signal comes in, that's where it's at. And that's what we have on here, is that these EQ knobs are at 0, meaning the frequencies coming in are not being boosted or attenuated, brought down. And so this gives us the ability to select certain frequencies within this range. and turn them up or bring them down. And so why would you do that? Well, let's say you have a really low, boomy voice, and it's sounding really low and boomy through the system. Well, you can, easily go and cut out the low frequencies, or if you have a high voice like I do, you can bring a little bit more in. And so you're changing the color of the sound. And here I'm going to adjust the mid frequencies. And this is just one representation of an equalizer. There's different kinds of equalizers that have a lot more controls than just 3. Like some of them have 32 bands, or if you're on a computer, then there's unlimited options within that range. And then here's the high frequency. So you can hear that this brings out a crispiness, like a brightness, for this particular microphone. So another use case of EQing is when you're mixing multiple instruments together. If you had a mix happening, whether you're doing sound for a band or you're working on the computer and you're trying to EQ stuff, you can have clashing happen if you've got your guitar and your piano playing similar frequencies via just the notes you're playing might be in the same frequency range. And so you can carve out space for each of those things by taking things down or turning them up so that they have their own space to exist in. And that's kind of a mixing technique, both in the studio and in live. And like Lene, I think for you, because you do sound bowls, that could be a really useful technique. You pick your bowls that you want to have their own, particular space, or if you've got a low bowl that you want a little more bass, just, crank it a little bit and it brings that out. Okay, so let's take a step back and look at another microphone. So I've been using the dynamic microphone, which is a very common microphone for most applications that are going to be like someone talking, or you're putting it directly on an instrument. And microphones have different patterns, and that means it's a polar pattern, and that is the what? Oh, all right. Okay, so polar patterns are a representation of where the sound gets picked up. And so right now I'm talking into this dynamic microphone, and if I move it like this, you don't hear a sound. If I'm over here, you don't hear a sound. It's very much directional. And this one is a cardioid microphone, and I'll show you some charts in a second that represent this. And so there's other microphones that have different patterns, where I could be over here and you'd hear me just fine, or I could be on this side and you'd hear me just fine. And so you use different patterns depending on what you're trying to pick up. And that's a very technical choice, because sometimes it's to avoid feedback, sometimes it's to pick up all the sounds in a room, sometimes it's to pick up reflections off of surfaces, because you're hearing me through this mic, but if I talk in here, you can hear the room. So my voice is bouncing off of everything in here, and I could use a certain type of microphone to capture that sound, and that becomes a creative tool, basically. Or if you're like, I don't want it to sound like, I don't like the way the space sounds, then you would use a microphone that is more directional and not picking up the ambience. And you might also use less gain, because if I crank the gain on this microphone, it's inherently going to be more sensitive. It's going to pick up more in the room, and we'll look at that with a very sensitive microphone. All right. That's where we're at. Hello. Hello, hello. Can you hear me at all through the... Oh, I don't have my aux send up. Okay, 1 second. All right, so a big part of audio engineering is troubleshooting. So I wasn't getting sound, and so I have to figure out, okay, why not? What's the problem? So I've got my The first thing I checked is that it's got gain. And I also had to figure out which channel it's on, and that's really important, is keeping track of your channels. And I kind of mixed my microphones up, so then I became a little unclear of which channel. So labeling stuff is really useful. Color coding, because then you can easily just be like, oh, that's this channel is this mic. And then you also look for signals. There's metering, there's LEDs. When you're talking, that's one of the first places to look if you're trying to see what's happening, is look at your visual companion. And then what I've realized is that I didn't have my aux send turned up. And so an aux send is an auxiliary send that takes the audio coming in and it sends it out to an additional output on the board, which in this case, that aux send is routed to this speaker. And so even though I had my microphone turned up, I didn't have it sent to the speaker on a separate knob. And so that's why it wasn't coming through. And so now if I go back, hopefully, okay, it works. So this microphone, which is, you can hear it's starting to feed back because it's so sensitive. It's that extra overtone harmonic that's coming through. So I'm going to turn it down, actually, and bring it over here. And this microphone requires phantom power, which is an extra 48 volts of electricity. It's just an option on the board that you press because it needs more voltage to do its thing, basically. And it's a condenser microphone. So we have our dynamic, and we've got our condenser. And this one is a large diaphragm condenser. And I'm going to pass around another one of the same so that you can look at it. And there's a few things to note. So there's a -10, 0, -20 switch. That is a pad, and it just reduces its sensitivity. Like if you've got a really loud source, a loud SPL, sound pressure level, and you don't want it to overdrive your circuit. You can use that, or you can give it extra gain if you've got a quiet source. And then it has this little 0 and HZ for hertz symbol, and that is a low cut. And that allows you to take out low frequencies at a specific frequency that often are unnecessary and can muddy up your mix, which is useful in a live situation, especially because if you get a bunch of low frequencies happening at the same time, it starts to create just mud is the best way to put it. And you can get feedback issues with subwoofers. So that's just a switch for that option. I like to keep my microphones when I'm working in the studio just at 0 because I can do that in post. So I just like to have that option, but it is a useful tool. And then you've got your polar patterns. So I'll pass that around and you can look at them. And there's one that's just a circle, and that is omnidirectional, meaning that the microphone picks up sound from every direction, from the front and the back and the sides. Then there's a figure 8 polar pattern, little infinity symbol on there. And this microphone has 2 capsules. So there's one on the front, one on the back. And when you put it on figure 8, it rejects sound from the sides, and then it just takes sound in from the front and from the back. You could use that if you've got 2 singers. You could have someone on each side doing a harmony. I've used it on miking the underside of a piano. Just put it underneath and have some of the frequencies of the bottom of the piano resonating down and then picking up from the floor, resonating back up. And when I was miking that piano, I played around with figure 8 versus Omni, and I just liked the sound of the figure 8 better. The Omni just picked up, too much. So that's a big part of audio engineering, is just trying stuff out until you get what you like to happen. Okay, so here's our large diaphragm condenser. This has a different topology from the dynamic, meaning that it doesn't have that same moving coil. It's got this really thin membrane in there that's like sputtered or covered with a layer of gold, and it's very sensitive, and it converts the current in a different way, and it converts the sound in a different way. And so these things will pick up this whole room like no problem, with even half the gain turned up. And so that's really useful if you're trying to mic a small ensemble or a room with just one microphone. You could use something like this to accomplish that. If you are doing vocals for a pop song or like anything really, these microphones work exceptionally well for capturing detail, and low end, bottom end, and they're very sensitive, and so you can get a level of detail that you couldn't necessarily with your standard dynamic. So I'll talk into this so you can hear a little bit of what is happening. Hello. Okay. So here's my voice, and you can hear how crisp it is. Just, I haven't done any EQing. And then here is the dynamic mic. So very, very different than this microphone. It's a lot brighter right off the bat. And I could talk back here, you could still hear me. So just different mic, different tool. And yeah, I think I'll leave it at that. And then move on to the small diaphragm condenser. So this is a similar microphone in the way that it has that condenser capsule, but this one's much smaller. And this is the capsule itself. And you can get different capsules that are omnidirectional, are cardioid. Just pop them on there. And these are great for smaller frequency ranges. Like this will pick up a lot more because it's got a bigger diaphragm, it's more sensitive. This you could use for overheads on a drum kit or on a guitar neck. It'll capture like a lot of that brilliance. And in a second we'll plug these in on an instrument and you can hear basically how that works. So I'm telling you all this because you should know that there's different types of tools that you can use to get different sounds. None of them are inherently good or bad or better. Even a really cheap microphone versus an expensive one, they just have a different quality to them. And audio engineering to me is really about working with what you've got to accomplish the sound that's in your head and using the tools at your disposal. So we're going to take a break from the mixing board for a second. I'll just quickly show you some other microphones. This is also a dynamic microphone. It's used a lot for broadcast. I like to use it on a kick drum because it's got a larger dynamic moving coil in here. It just really works well for that application. This is a stereo condenser. And this has a front capsule, and it has a left and a right capsule. And I love using this to mic a whole room or on cello, and you can adjust how wide of a frequency or how wide the sides are, basically, that you're capturing. So all just different tools. And then there's things like a DI box, another important tool that takes a high impedance signal, which typically comes from like a guitar, for example, because a guitar doesn't produce a lot of signal on its own. There's just a little magnet, like an electric guitar. There's magnets, wound around a pickup, and the strings are above that, and the magnets capture that vibration, and then they send it out. But it's a low level signal, and it's high impedance, meaning there's a lot of resistance and ohms. And so this box just takes that and it sends it out so that you can have it as a microphone level signal, which is a little bit hotter than a high impedance signal. And then beyond that, like a line level signal is something that has a lot of gain, like a synthesizer, for example, or the outputs of this mixer to the speaker, those are line level. And so you've got different levels that you need to know the definitions of, what they do, how to use them, and if you're not getting the right signal, sometimes you need to use a tool like this. Similarly, this is a little preamp booster box, because there's some microphones that require so much gain that I would have to crank it all the way. And at that point, you start to introduce noise on your mixer, because these preamps just don't have the ability to send that much power before they get noisy. And so something like this just has a transformer inside of it that boosts that signal. Yeah. And then we've got a cable tester, really useful tool. If you've got a cable that's acting funky, or you're building a cable, you just plug it in one side. Like so, and then you plug it in I guess that'll do, the other side. Okay, and then you've got lights on here that tell you if you have a connection on each of the pins, and whether or not it's grounded. So that's an important tool that I use a lot. And with that, let's get back to cables and pins. So the XLR has those 3 pins, and they connect to 3 pins on the other side of the XLR cable. This cable is XLR to 1/4 inch TRS, meaning tip, ring, sleeve. So this is the tip, and then we have a ring and a sleeve, these other 2 little lines on here, and those send additional signals. Well, those are your signals being sent across this cable. And so a standard aux cable that you might use for your car, like a 3.5 millimeter, or for a boom box, that's the same thing. It's a tip, ring, sleeve cable. And it's primarily different than a tip sleeve cable, a TS cable. So I'll pass around each of these, and you can see the TS versus the TRS. And this is a really critical thing to know about, because a lot of times you'll need to send a stereo signal somewhere, and if you use the wrong cable, if you use a TS, it's going to come in mono. And so if you're trying to set up a PA or something, and you're using 1/4 inch cables, make sure you have the right one. Guitars just use a TS cable. The first one, or one of those that just has one little ring around it, the sleeve ring, because they don't need that extra input, because they're just one source, and they also are grounded through the amplifier. Okay, so we've talked a lot about cables. Does anyone have any questions? Yes. Yeah. Can I give you the microphone?
There are so many different the little cables that you were passing around, or actually the little inputs that you were just describing with the, we call them the female or the male sometimes when they have 2 lines or 1 line. We refer to them as male or female. And I tell you, sometimes when I go to plug up things, you're absolutely right. It does make a very big difference in which one you use, but there's so many. You know what I mean?
Yeah.
With the little one, the tiny one, there's so many. And when I used to, before learning and knowing which one to use, and even now I still have to really think about it sometimes, because you have to use those different inputs and those different things. And you're right, it does mess with the quality of the sound. You would not think that, but a lot of times things don't go through, or things
Yeah.
don't come out. And I learned that the hard way because I'm like, what's wrong with this? I'm putting this in, it fits, but why isn't it going, I didn't realize that there was a difference between there was one line here and there's 2 lines on this. And a lot of people don't know that. And
Yeah.
that makes a very big difference. And I had no idea that it made a difference until someone taught me, hey, this is 1 line, and this is 2 lines, and this is how you distinguish. This is the
Right.
one that goes here, and this is the one that goes there. Even on the big, the RCA, the different ones that you named. So that really helps. And I was very confused about that for a long time when it came to audio. And when it came to check out things, it's like, what part do you need? It's like, I don't know. Because
Right.
there's so many different ones. So thank
Yeah.
you for sharing that because it's very important.
Yeah, there's so many cables and so many adapters. Like this is a stereo TRS to TRS that I'll use if I have like a cable that's not long enough and I just need to link 2 cables. But this tool is stereo. So if I was trying to send across one of these that was mono, a TS cable, it wouldn't work. So yeah, you just got to look out for, just think about your application, what you're trying to send. That sort of topology is like, what is my source? What is my destination? What do I need to get it there in the cleanest way possible? Yeah, and sometimes that has to do also, like talking about cleanest way with your cable management, because that helps you figure out what's going on. So like you can see here that I have my cables wrapped around my microphone stand, which just kind of keeps it tidy. And for this microphone, it's fine because I'm not taking it off. But for the SM58, you don't want to wrap it around because then if you need to take it off to move, you can't. And so that's an important part of the engineering process. When you're setting up a stage or a space for yourself or for others, is thinking about how is this going to be used and how can I make it the easiest so that everything flows well. Okay, well, I've got more stuff I could talk about, but I'm really interested to hear if you have questions that you're itching to know about audio and sound. Tyrone?
I have a question. When recording on in your DAW, digital audio workstation, what's the best frequency to use? Like 44.116, what's the best one to use and what's the difference?
Thank you. Okay, so Tyrone is talking about recording audio inside of a DAW, which is a digital audio workstation, a computer-based piece of software that takes audio in, allows you to process audio, and allows you to bounce audio out. And Tyrone's question was about sample rates. And so in a digital audio environment, you're working with samples, which is a representation of just a little chunk of a waveform. So let's just say I'm singing a song, it's just an a cappella, and my voice gets recorded in. In an analog scenario, that waveform just gets converted to electricity, gets back pumped out through the speaker, it stays all analog. In the digital realm, it has to be converted through something called an AD, an analog to digital converter, which looks at that analog signal and it processes the waveforms and it assigns samples to to a variety of little nodes of the waveform. And so when you use like a 44.1 sample rate, it's 44,000 samples per second that are being analyzed, basically. And so if you have a waveform, I'll just demonstrate down here. So let's just say this is a sine wave, okay? It's got frequency, which is how often these little, ups and downs happen. They could happen closer together, faster frequency, slower frequency, but it's still a sound wave. So basically, between here and here, a sample rate says this is all the information that's occurring between this location and this location, and it has to step up bits per every little every little step of this amplitude increase. It analyzes it and it says, okay, this is this waveform represented back through digital. And if you have a higher sample rate, then you've got more of these samples per second, and so it's more information. And sometimes that translates to perceived change in fidelity. Like if you use a really low sample rate, like 8-bit music, maybe some of you remember like the Game Boys and the sounds that would come from that. That's super low, and it has that kind of like distorted bit reduction sound versus today's modern audio is really high fidelity and crisp. CDs being at that 44.1, that's like the standard for CDs, and that's the maximum that they can handle. And if you go higher than that, it will sound better up to a certain point. But there's a range as far as the equipment that you're sending it through to listen, and your ears and how trained they are. Like most people can't hear a difference at 92,000 samples versus 48, maybe even 41. So yeah, it just depends. But if you're doing a professional project, like you probably want to be working in the highest sample rate that you can, because it gives you more room to work with. And there's a lot of more advanced mathematical things that are happening too with the Nyquist theorem and the way samples like add up to create harmonic overtones. And so we could get into that at the advanced audio class that I'm teaching in May in digital audio workstations. But the main thing to know is that it sounds better up to a point. And it requires a lot more space. Like if you record at 44.1, it uses less space than 48 or 96 because you have less data being assigned to each little step of your waveform. And so if you don't have a ton of hard drive space, it can make a pretty significant difference in your projects. And so just a thing to know. Any other questions?
When you were demonstrating the difference between the dynamic and condenser mics, you noted that the condenser mic, your voice sounded more crisp and more bright, whereas with the dynamic mic, your voice sounded more boomy. And I was wondering, one of the things that could be happening is that there's a proximity effect with microphones, right, where you hold the microphone very close to your mouth, and that makes your sound more boomy. Are you implying that the condenser mic does not have proximity effect?
Great question. So proximity effect is when you get closer to, hello. Okay, we're back. When you get closer to a microphone, low frequencies, which is a little bit hard to hear in this scenario, but low frequencies get exacerbated, partially because they're resonating off of the surface of your mouth, and a condenser microphone. You can reduce the proximity effect because you're typically farther away. But yeah, the coil in this microphone versus the capsule in there respond differently to different frequencies. And so you could get a lot more low frequency out of a condenser that wouldn't have that same proximity that a dynamic would. Yeah. But that also brings me to access. So you could place a microphone on axis like this, like let's say on a guitar, and I think we might have a couple minutes. We could end with miking an instrument, where if you put this right to the sound hole, of a guitar, you'll get the same proximity effect problem. But if you put it off axis like this, it is not going to have the same proximity effect. And so those are just mic placement techniques, which I'll get into in another class as well. Yeah. Did you have a question, Lene?
So then, what have you found has been the best way to mic singing bowls if I was to do? I understand now why you suggested I take this class, because yeah, I can't even think in my mind how you would mic myself, because I want the headset mic so I
Oh,
can
yeah.
move around, right? So to mic myself and the singing bowls with having the high frequency and the low. So is that multiple mics and you don't want yeah, what are your suggestions for that? What have you found
Yeah.
for that? Seems like an interesting soundscape as opposed to just standard, this is a band and here's each.
Right.
Yeah.
Yeah, I love that question. I have been on a journey of trying to record singing bowls in a couple different, with a couple different people, a couple different types of bowls, and it's really tricky because singing bowls send sound, into the whole space. They're omnidirectional in a very expansive way, and so I've used large diaphragm condensers like in the back of the room, but then the issue is that they pick up the body movements of the singing bowls and whatnot, and that's a challenge. I've done close miking. You definitely have to watch what you're wearing.
Record, I would need to have clothes that didn't.
Yeah, that's a big piece. And the headset you could just have on a separate channel. So that comes in, and then you've got a different mic for your bowls. And I like to have a room mic for singing bowls that's a little bit farther away that captures the ambience, because then you're not at risk of capturing that close.
That low bowl.
So for the low bowl, I'll usually hang like a dynamic mic right up above the rim, and there's a really special spot like that I've found on certain bowls where it really just starts to capture it on the mic. So it's usually a multi-mic situation. At least 3. It depends how many bowls you have. So that might mean, it depends on the quality of the recording that you're going for, both in terms of like the fidelity and the quality in terms of the texture and the sound. Because if you mic bowls up really close, it's going to sound kind of like you're like right next to the bowl and inside of it. But if you're miking for like a video performance, sometimes that can create a bit of dissonance between what people are seeing and hearing. And so like here we have this room mic in addition to this mic, and it gives people a sense when they're watching this broadcast of the space that we're in, and it brings you more in connection with that. So it's usually a blend, and it depends on if you're doing a studio recording or a live recording. Yeah. Yeah. Any other questions? Okay, I think we've got like 4 minutes. So I would love to do a little microphone demonstration for you with a guitar. Does someone want to come and play? Just strum a little bit of guitar. Doesn't need to sound great. You could even just do an open strum. Oh, I have 15 minutes. Oh. Oh, okay, sweet. We got 15 minutes. Yes.
Audio is going to be. If you ever watch Beyonce, she gives you that look like, what's up? Fix my Beyonce, fix my stuff. So it's like, I try to explain to them, when you are a vocalist, you hold the microphone up to your mouth when you're singing low, because I have a very soft voice. So you put it up to your, but when you're screaming and you're belting, the microphone needs to be out here somewhere. And a lot of people that don't know about audio don't realize that. And they'd be like, well, you need to sing up, you need to speak up. No, if I scream in this with this up to my mouth like this, it's going to sound horrible, and you're going to run away from me. So that's why I'm holding the microphone out here, and I've had to, that's been a struggle with some audio people not understanding that you have to have control with the mic,
Yeah,
with your voice
Totally.
when you are a vocalist. And they need to understand that it's different for everybody. If you have more than one singer, you've got to adjust that microphone for that singer. And that's usually done in pre-production when you're going through the dress rehearsal. But some of them still don't understand that. They're up there playing with it and messing with it, and you're going, "Oh, what's wrong?" You're getting frustrated because you're singing, you're trying to, and you're like, hold the microphone up. I don't want it up to my voice because if I go, it's going to sound horrible up here, you know? They don't understand that.
yeah, and a lot of people too, like, don't have experience working with a mic, like you're saying. And a big piece of it too is monitoring. So right now I'm sending a separate feed through here than what's going to like the main, mix for this recording. And on stage, or even if you're, recording yourself in a studio, you could have headphones that have the same mix coming through. Or it could have a different mix. So you could have more of your vocals, more guitar. It's a separate kind of thing. And that helps you hear what you want to hear to be able to connect with the music. And so if you're doing live sound or if you're setting it up for yourself, think about the performance you're trying to get out of the artist or yourself and what you need to do to get them there. Like sometimes I'll have a vocalist singing and they're really quiet. And I'll turn up themselves in the monitoring so they can hear themselves better. Sometimes that works. Sometimes they're too loud in the monitor, and that's why they're singing quiet, is because they can really hear themselves too much. And so sometimes you have to turn it down. And that's more of a production observation. Just know your artist and kind of how they respond. But yeah, there's certainly like times when a vocalist is singing and they're gonna really belt it, that they should move the microphone, back, and that's just mic technique. And so that's a big part of engineering is guiding people in that way too.
Yeah, so that was the other thing that I was interested in about sound, is that the albums that I've been recording my poetry like this into the album. But that's not how I perform. I perform like this. I'm like, put the mic down, honey, I don't need one. So then how so then how do I bring that together? Like, do I perform away from a mic and then record it that way? Like, even though nobody's there? Or
Totally.
like, yeah.
Yeah, that's exactly what I would recommend for you, is setting up room mics and then performing for the room, because that's what the audience would hear. And you could also have a clip-on mic like this too, to get that fidelity and that close sound, and you can blend those in as well. But
we've got to figure out something to have the recording come across, something between the live.
Right.
And not just, because my speaking voice is not my entertainment. And I'm recording like that as opposed to.
Yeah. So let's see how that translates to the guitar here. So first thing I'm going to do is check what settings we have. Okay, so I put this into the cardioid setting, meaning that it's mostly focused kind of in this zone, and it's rejecting all this stuff. There's also a supercardioid and a hypercardioid, which are just more and more narrow. This one just has cardioid and hypercardioid options, but we'll see if we need that. But I'm wanting to direct here so I can really get that full body of the guitar. And this is placed, pretty far away compared to where I would have a dynamic. A dynamic I would put right up on the sound hole, because it's not going to capture the way that this will. So let's hear what that sounds like. Go ahead and strum some guitar. Okay, so that's pretty good. You can hear the whole guitar. What happens if I move it, let's say, over here and play? hear it, but it's a lot more thin because it's not catching that sound hole, and a lot of the warmth of the guitar is coming off of the body that's resonating. And so if we got even closer, the first thing I'm going to do is turn down my gain because it's going to be louder at this point. And ideally, like, I'd have a shorter stand and I could get down here so you could really hear, but I guess I can physically do this. Okay, so if I move up here, you hear more of the strings. Is that coming through loud enough? Because I turned the gain down. Okay, so you can hear the placement of the microphone really affects the sound that you're getting out of it. Let's try the dynamic mic. Okay, so go ahead and do the same thing. It's still there, but it's not as full and present. Not really hearing much. If I go down here, it's a little bit, but for the most part, like, that's where it comes through. And so if you only have a dynamic mic, you gotta know where to put it. Sometimes I'll do multiple mics because you get the multiple timbres, which is just the quality of a sound. Yes.
What about a combination of like a pickup in the acoustic guitar
Yeah.
in addition to the condenser microphone?
So
That kind
I
of gives the
have,
closeness and some of the room at the same time. Would those have an issue between the two of them in any way, as far as like feedback or anything going on?
no, so feedback is gonna occur when you have your output, like the speaker, getting picked up by the microphone that's sending into it. And so because this is set to reject the sides, it's not picking up the room reflections, but if I put it into Omni mode, it would start picking and it might not feedback in like the wah kind of way, but it would start picking up feedback in maybe even a musical way that you could use. So baffling sometimes is very useful. Like you could put, you could build something on wheels or put a mattress to kind of try and keep sound out, because even though it's in that directional position, it still is capturing the sound of the room to some degree. But yeah, if you put another microphone on there, it's not going to feedback. You're just going to have more texture to play with. And so if you have the luxury and the privilege of multiple mics, like totally invite you to do that. And then when you're mixing later on in the box, or if you're doing live sound, you can create a sonic palette that's unique because of that. So will someone come and hold this up, and we can demo that? Just like hold this kind of around the sound hole, and you can play around with different positions. And then I'm gonna play with blending them together. So right here, we are only listening to the large diaphragm condenser. And then I'll solo the dynamic microphone, which in this case is actually bringing a lot of nice like mid-range and body. But to my ears, it's a little bit mid-rangey. And so I'm going to use this mid-range EQ and tuck it out a little bit because it has that proximity effect. That's what that's coming from. So now if I blend in the other one, you get a really nice full sound. That's just the condenser bringing in the dynamic. And I'd be pretty happy with that for recording. It doesn't take that much. We could also have a room mic. Would probably be like the last thing. I've had 6 mics on a guitar once when I was at Evergreen in the studios, just because I was experimenting. And you can use that. You're good if you want to But you're also welcome to keep playing with that, but no need to. You can, if you have that many inputs coming in, that gives you the opportunity to like solo them all and blend them and see what you like, especially if you've recorded them. And you might get to a passage of a song, like the bridge or something, where you want a different quality of sound. And then just switching to the different microphones that you recorded allows you to do that in a really subtle way. Yeah, yeah, yeah. So yeah, thank you. Okay, any other questions? Yeah.
Power supplies, and a lot of times you'll have everything set up right, and then you get this noise coming from a power supply, and you don't necessarily know how to fix it. I know they have power supplies that will have certain things built in, like, I don't know, there's some acronyms that say like it's kind of like like the protected cables you were talking about. How important is it to get one of those special power supplies with recording, would you say?
Well, it depends on how dirty your power is. There's a lot of situations where the power isn't great at a location, and you can get a lot of like RF, radio frequency interference. The power might not be super stable. Like you usually want between 118 and 123 volts of stable power. Otherwise your equipment can start acting funky. And then what you're talking about is most likely like grounding stuff. So a lot of DI boxes have ground lifts, and that's a tool that can help to isolate your signal chain. There's different tools like power conditioners that do a little bit to cancel out that hum, and usually it's like a 60 hertz hum. And so you can use, if you use shielded cables, that can help. And if you use, like, yeah, there's just a bunch of different tools.
It could be something like your refrigerator, your this, or something in your house that could be, you know, turn that off for now, and then that sound goes away. There's a lot of, like you're saying, dirty
Yeah, the best way I would say is to try and isolate it. So if you can be on a different circuit, so just find where your circuit board, or for your house or wherever you're at, connects to. Okay, so that is our time for today. Thank you all so much for coming and asking questions and participating.
Let them know about your class.
Yeah, I'm teaching this class on multi-track recording, mixing, and editing in May on Saturday. It's a 3-hour class, and we'll be diving into this stuff even deeper, but more from a recording perspective. So we'll be taking these inputs and sending them into a computer and figuring out how to do that. And then once it's in the computer, how do we mix it? How do we, EQ it? Adjust things like phase, etc. And there's computers available here at TCMedia to use. And I think that there's a maximum of 6 slots. For that. Yeah, so that class is coming up. And then I also teach private and group music and recording engineering lessons, which I'd be happy to talk with you more about too if you're interested in that. My studio on the west side of Olympia.
Rocco, do you want to also tell them about your own stuff, your own opportunities? I'll pull up your...
Oh yeah, if you've got the flyer kind of for what I was just speaking of, and yeah, I have a studio where I help people record songs and albums and learn technology and how to use synthesizers and microphones. So there's a little flyer. So make a demo tape. I also do field recording if you're interested in learning how to take field recorders, which TCMedia has for checkout, and go and capture natural sounds or record your music outdoors just with a portable device, which is actually just as powerful as this mixer. It's just battery powered, and you can plug in like 4 mics to that. Yeah, so yeah, and then I also teach like sound design, how to start from scratch from either sound you record or with a synthesizer and add that into film. Yeah. Yeah, and feel free to stick around afterwards if you have other questions or want to connect. All right, we're off the air. Yeah. Thank you.